Morning, kids, and welcome to physics this week. And this is the last lesson on this unit, Unit 3. And today's lesson is about density. And the first thing I want to go through is the objectives of what we're about to do. I want you all to be able to define the word density and the equation that is involved with it. I want you to be able to use that equation to calculate density or mass or volume, given two of those three quantities. And then I'd like you to explain the differences in density between solids, liquids, and gases, referring to the particles, atoms, molecules within them. So that's the plan for this lesson, okay? It's a shame we're not in the classroom doing it. So there's the four words that are going to be used the most today: density, mass, volume, and particles. Right. So what do we already know? We already know there are three states of matter: solids, liquids, and gases, right? So solids have strong forces of attraction, holding the particles close together in a fixed regular arrangement. We call it a lattice, as you can see from the picture there, right? There's very small gaps between each particle. They don't have much energy, so they can only vibrate about their fixed positions, right? They don't go moving particularly, which is why they are in a solid state. They just vibrate a lot. And of course, when you heat them up as well, they vibrate faster and further apart. So that's a solid. A liquid, weaker forces of attraction between the particles. They are close together, but they can move past each other, which is why they are fluid and take the shape of the container they are in, okay? They have more energy than the particles in a solid, and they move in random directions, which again allows them to take the shape of the container they're in, but they move at low speeds, okay? So that's a liquid, so slightly less ordered than a solid. And then, of course, we have the third state of matter, the gas. There are almost no forces of attraction between the particles there. They have more energy than those in liquids and solids, and they are free to move, which is why we get diffusion, which is why if you spray an aerosol in one part of the classroom, within 30 seconds, you will smell it at the back of the classroom, okay? Because they are free to move and they are constantly moving in random directions and random speeds, right? Now, those three particle models of matter will allow us to figure out about density in each type of state. So density is a measure of how much mass has been packed into a given volume. So there's those three words again: density, mass, and volume, okay? Which basically means how heavy one unit of volume of the material is. And of course, the reason we know different materials have different densities is if I had a block of, say, wood in one hand, but a block of concrete of the same volume in the other hand, the concrete would weigh more. And that is because it is more dense, okay? Obviously, we're measuring mass in grams and kilograms and volume in centimeters cubed or meters cubed. You could use millimeters cubed if you're talking of very small objects, and you could use micrograms as well. So something we consider as heavier has a higher density, which means it's more dense. Something we consider as lighter has a lower density, it's less dense, right? So all pretty self-explanatory so far. So here's the mathematical formula that you will need to remember for your exam. Density is mass divided by volume, right? And you've probably already done this in mathematics. And you can put this in a triangle formula like distance, speed, and time. The actual notation for density is the Greek letter rho, right? You'll do that if you take A-level physics with me as well. So the Greek letter rho is m divided by volume. And of course, that can be rearranged then. So mass is density times volume, and volume is mass divided by density. And we'll play around with that in a moment, right? The units, the preferred units of mass, what we call the SI unit, the System International unit, is kilograms. The preferred unit of volume is cubic meters, and therefore the preferred volume of density is kilograms per cubic meter. Of course, we don't often have cubic meters of materials, so that can be changed to grams, centimeters cubed, and therefore grams per centimeters cubed. But the preferred ones are in red there, and I want you to know that, okay? That might come up on a test. Right. What happens if we don't know the volume of the item we're trying to measure the density for, but we know its mass? I.e., what if it is an irregular shape, right? Because in a moment we're going to look at volume of cuboids, and you know that's length times width times height, or cylinders, which is pi r squared times the length of the cylinder. But if you have an irregular shape, and you might do this in a practical in class one day when we're back, all you do to work out the volume is you get a cylinder and chuck some water in it and make sure you accurately measure the amount of water in it. Throw the object in the cylinder, and of course, due to the effect of displacement, the water level will rise. Take the difference between those two measurements of water, and that will give you the volume of the irregular object that we're trying to calculate, right? Then you can chuck those numbers into the density formula, mass divided by volume, to get its density. So remember that, okay? That does come out occasionally. How would you work out the density of an irregular object? And that is how you find the volume of it. Chuck it in a cylinder of water. Right. So it's time for you to start doing something. So I hope you've got a pen and a scrap bit of paper. I'd like you please to calculate the density of a 50 kilogram cube, which has a volume of 2 cubic meters. So it couldn't be easier, right? There's the triangular formula. So density is mass divided by volume. The mass is in kilograms, the volume is in meters cubed, so you don't have to play around with any units. I'm sure you've already done that in your head. Density is mass divided by volume, which is 50 divided by 2, which is 25. Now make sure you get the units right, kilograms per meters cubed, okay? So it's as simple as that. So 9 times out of 10, I'm going to give you 2 of the 3 variables, and you've just got to figure out, do I multiply them or divide them, and get the units right, okay? So let's have a look at another one. Number 2, calculate the mass. This time, the mass of a container, which has a density of 100 kilograms per meters cubed and a volume of 0.5 meters cubed. So let's look at the units first. So the density is in kilograms per meters cubed and the volume is in meters cubed. Great. So when we calculate the mass, it will be in kilograms. So think of your triangular formula. We want the mass. So looking at that there, I need to do the density multiplied by the volume. I'm sure you've already done it. And 100 times a half is 50 kilograms. Right? Easy peasy. Okay. Let's look at the next one. Let's see if you spot anything here. Calculate the volume of a ball, which has a density of 2.5 kilograms per meters cubed and a mass of 5,000 grams. Okay, so this one's got an extra tweak to it. My density is in kilograms per meters cubed. That's great. That's what I want. But my mass is in grams. So the first thing I need to do is convert that into kilograms. I'm sure you all know there are 1,000 grams in a kilogram. So really, I'm going to be looking at using a mass of 5 kilograms. To get the volume, I do mass divided by density. Sure you've already done it by now. Volume is mass divided by density. Convert the grams to kilograms. It's 5 divided by 2.5, which is 2. And of course, because it's volume, the units will be cubic meters or meters cubed. Right, no problems. Let's do one more. Let's do one more. Let's take it up a full notch now, right? Calculate the density of a 50 kilogram block. The block's length is 4 meters, its width is 2 meters, and the depth is 1.5 meters. So we have the mass, and we have its length, width, and depth. I think we ought to assume that the block is a cuboid. So we're going to have to work out its volume by multiplying the length, width, and the depth. Once we've got the volume and we know the mass, we can then work out the density. Okay, so giving you a couple of seconds there to work out the volume, length times width times depth. I'm sure you've done it by now. And then once we've got that, which I believe is 12, the volume, the density is mass divided by volume. All the units are correct. We've got a mass in kilograms, a volume in cubic meters. I'm going to do 50 divided by 12, and it's 4.17 kilograms per meters cubed. And that's the type of question you're going to get on a test. All right? Awesome. Okay. This is what I would like you to do now. I'm going to ask you to press pause in a moment and give yourself 60 seconds. You don't need more than 60 seconds to try those 7 questions there. A little progress check of what we've done over the last 10 minutes. So press pause now, please, and have a go at them. Off you go. Right, great, we're back. Hopefully you answered those 7 questions. So what is the definition of density? It's the measure of how much mass has been packed into a given volume. Please don't use the word weight, okay? Try and use the word mass. How much mass has been packed into a given volume? What's the preferred unit for mass? Kilograms. Which of those following is not a unit of volume? There's 2 of them. We have millimeters, which is a length, and we have meters squared, which is an area. The other 2 are volumes. What is the preferred unit for density? Kilograms per meters cubed. Write down the density equation. So with volume as the subject, right? So volume is mass divided by density. So V equals M over rho, that funny looking P symbol. Convert 750 grams into kilograms. That would be 6.75 kilograms. And then the challenge question was a standard form question from mathematics. The volume of a gold bar is 6.3 times 10 to the minus 4. What is that as a decimal in normal form? So I've got to move that decimal point 4 places to the left. So it will be 0.00063. Okay, there were the answers. I'll put them up on the screen. So there are the answers there to that progress check. Okay, let's move on. Oh, yeah, write down how many you had right out of those 7. You're going to need it for later, right? It's going to determine what work you do at the end of this lesson. So give yourself a total score out of those 7 and just jot it down somewhere. Fab. Right, let's keep talking then. For most substances, the change going from a solid to a liquid does not mean a big change in volume. So let's talk about the most obvious one, ice and water, right? If I have a block of ice and it melts into water, the actual change in volume won't be that much, right? And that's because the particles only move slightly further apart when you go from a solid state to a liquid state. So the density of a solid is usually slightly higher than a liquid. Not by much, but slightly higher. And you've got that little diagram there to show us that in a solid state, if I had 1 cubic unit, I would get that many red particles squeezed into it. And in a liquid state, because they've moved slightly further apart and in a bit more of a random arrangement, there'll be slightly less particles, meaning slightly less mass, meaning slightly less density, okay? So that's why that occurs. So as you go from a solid to a liquid, there's not a great deal of change in volume, so not a great deal in change of density. However, when a liquid changes into a gas, so let's stick with water, right? So now we've gone from ice to water, and now we're going to heat that water and it'll turn into steam. And when that liquid changes into the gas, the spacing between the particles increases significantly. The molecules spread out much more. And if we look at our cubic unit there, if you look at the scale, there's actually, that box now represents 10 of those cubes on the previous slide, 10 of them. And look how few particles are in that box. There's 10 times the size of the original one. So that means there's a heck of a lot more volume, but a lot less mass. So the density decreases significantly, okay? So more volume, less mass, means the density decreases significantly when you go from a liquid to a gas. And it's because there's less molecules, much more spread out. Now, when a gas condenses to form a liquid, so when steam cools down and it condenses to go back to water, its volume then decreases significantly. So this has the reverse effect of what we just explained, and the density will increase again because the particles start packing back in more tightly, right? So here's your next progress check. So 6 questions. Again, I'm going to ask you to pause in a moment, and you're going to try and jot down some answers to these 6 questions, right? And of course, I've just gone through everything you need to know, so feel free to rewind if you want to get the answers, but it should all be up there. So press pause now and give yourself 60 seconds to try and fill that out. Off you go. Right, and you hopefully unpause now, and we're back. So the density of an object depends on what it's made from and how its particles are arranged, right? Or I will accept how its particles are packed, or I'll accept atoms or molecules instead of particles, right? But it's basically about how the particles are arranged. And what can you say about the particles in a dense material? They're very tightly packed, they're very close together. Which state of matter has the highest densities? Solids, because you get the more particles in the amount of volume. Which state of matter has the lowest densities? Gases, because there's very few particles, very spread out in a greater volume. What is the effect on density when a material condenses from a gas back into a liquid? The density will increase because the molecules become more tightly packed together. And then your challenge question, explain why there is very little change in density when a solid melts to become a liquid. So let me put the answers up and explain that last one. So there's the 5 answers we've gone through. So for most substances, the change from a solid to a liquid state does not mean a big change in volume. This is because the particles stay approximately the same distance apart, a bit further apart for a liquid. So this means that the density of a substance, for example, iron, does not change much when it melts. It will change a bit, and the density will decrease slightly. Fabulous. Again, give yourself a score. Add it onto your previous score, and then let's find out where you are. I'm sure none of you are between 0 and 4. I imagine most of us are in the green, and some of you may be in the amber 5 to 8. And depending on what color you've scored there, will determine what task you're going to do for me now to finish, right? So only 4 questions for task 1 and task 2. There's 3 for task 3. It's a bit juicier, and then there's a challenge question as well. If you really want to, you can try them all. They're not going to take long, right? 2 minutes tops. So in a moment, I'm going to say press pause again as normal. I'll scribble a paper. Try and do your selected task, or do all of them. Go for it. Why not? It's your last lesson before half term, and then I'll go through the answers, right? So press pause, give yourself a couple of minutes, and off you go. Right, and we are back. So I hope you found them challenging, but not too difficult. Let's go through them. The red, if you did it, the preferred units for mass, volume, and density, we know are kilograms, cubic meters, and kilograms per cubic meters. 9,000 grams is 9 kilograms. The density of an object with 25 kilogram mass and a volume of 12.5, mass divided by volume is 2 kilograms per meters cubed. And number 4, the density of a 15,000 gram mass object with that volume, convert that to kilograms, is 15 kilograms, divided by 7.5 is again 2 kilograms per meters cubed. Right, task 2, which I'm sure most of you have done. What's the density equation making mass the subject? So mass is density times volume. Convert 4,365 grams into kilograms is 4.365. Calculate the mass. If that's the density, 13.5, and the volume is 4. All the units look right there. So mass is density times volume. So if you times it by 4, just double it and double it again. So that's 27, that's 54 kilograms. Calculate the density of a 5,000 gram mass cube with a side length of 0.5 meters. So you might have fallen into the trap here and assumed that that 0.5 is the volume, and it's not, okay? So first of all, the 5,000 grams has to be converted into 5 kilograms, right? Now the cube means the length, the width, and the height are all the same. So it's 0.5 times 0.5 times 0.5, which is 0.125 meters cubed. So the mass is 5, the volume is 0.125 meters cubed. Mass divided by volume, I believe that would come out as 40 kilograms per meters cubed. Right, task number 3. A 36-gram object has sides of 6, 3, and 1. So we have to assume it's a cuboid. That 6, 3, and 1 is in centimeters. The mass is in grams, and they want the density in kilograms per meters cubed. So the first thing you've got to do is convert 36 grams into kilograms. So that's 0.036. The next thing you have to do then is convert the centimeters into meters. That's 0.06, 0.03, 0.01. And multiply all of them together, and I think you get 0.00018. And then the density is the mass divided by that volume. I'm not going to fib. I'm looking at my answer sheet here. That comes out as 2,000 kilograms per meters cubed. Number 2, convert 285 grams into kilograms. Divide by 1,000, that's 0.285 kilograms. And then number 3, a rectangular block, so again we assume that means a cuboid, of copper metal has a mass of 1896 grams. So that's 1.896 kilograms. The dimensions of the block are those 3 figures there in centimeters, and we need to know the density, right? So convert the centimeters to meters, so that's 0.084, 0.055, 0.046. Multiply those 3 together to get the volume, and then you'll do 1.896 divided by that volume, and the answer should come out as 8,922 kilograms per meters cubed. Now the challenge question was a cylinder, okay? Now to work out the volume of a cylinder, you have to work out the cross-sectional area, which is a circle, pi times radius squared. And once you've done that, multiply it by its length, right? So it gives us the diameter is 50 centimeters. So that means the radius would be 25 centimeters, which is 0.25 meters. So you've got to do pi times 0.25 squared times 2. That will give you the volume of the cylinder. Once you've got the volume, then you do the mass divided by that volume. And if you had it correct, the answer came out as 25.5 kilograms per meters cubed. And if you had that right, you should be very, very pleased, okay? So there's all the answers that I've just gone through there. So you can pause if you want to go through it again and mark off your score. I'd love you, please, to reply back when you hand this work in and let me know what you actually did score, and I will reward you accordingly. So here's a summary of everything we've just done, right, over the last about half an hour. And in fact, this is a summary really of the whole unit, right? So the first point talks about conduction, convection, and radiation, which we did 3 lessons ago. Then there's the density formula. Then it talks about how density changes during in the 3 states of matter: solids, liquids, and gases. Then we talk about thermal conduction and why metals are good conductors. And we talk about convection in liquids and gases. Remember that convection cycle we spoke about in a room with the heat coming from the radiator, hot air rising because it becomes less dense. Then we talk about energy losses from houses using insulation, double glazing, draft excluders, etc. That was last lesson. Then we talk about payback time. So that's if you invest something to save money, how many years does it take to make that money back? That was last lesson as well. And you need to know pretty much all of this stuff, because after half term, I think you're going to have a typical test. So I'll give you a revision map to fill out, like for the last 2 units, and then you'll have your test. Okay, so here is a very tricky GCSE exam style question. I just want to show you it because I might give you one as part of your test. And we're talking about wind energy, and they give us the area of the turbine blades. They give us the speed of the wind, and they give us the density of the air, okay? And we're going to work out the power of this turbine using that data, okay? So if we know the area of the blades and we know the speed of the wind, we can work out the volume of air moving through the turbine per second by multiplying the speed, which is in meters per second, by the area of each blade. So that's why they've done the 25 times 12 there. So that's 300 cubic meters. That's a volume of air going through every second. Because now we know the volume and we know the density of air, we can work out the mass of air going through the turbine, which is a very, very impressive 360 kilograms of air going through that wind turbine every second. Then we can work out the amount of energy that turbine is creating using the kinetic energy formula. Kinetic energy is a half times the mass times the velocity squared. So now we've worked out the mass is 360, so it's half of that. We know the speed of the air, or velocity, is 12. So chuck those numbers in the calculator and I get that amount of energy in joules. And then they tell us that the efficiency of this wind turbine is 25%. So how much power comes out of the turbine? Well, you have to find 25% of that energy. Of course, just multiply it by 0.25, and then you get the output power in watts. So that's what an exam question will look like. And I know that's a definite step up in difficulty, right? But it's there for you to look at, and I've explained how to do it. So if you do see one in the near future, you're not to be scared by it, okay? Right. Quickly now, just pick two numbers in your head from 1 to 25 and jot them down. Do it straight away, don't think about it. Pick two numbers from 1 to 25 and jot it down. And then your last task for me, please, is to have a look. Pick whatever your two numbers were, jot down a couple of sentences that relate to the two questions that you see on the screen now, right? And if you'd like to take a photo and upload that for me to have a look at, or even just type it in the chat, I would be very, very grateful. I hope you got something useful out of that lesson, kids. And I think after half term, we'll do a revision map on the whole unit, and then we'll have another assessment. And you never know, touch wood, we might see each other in person in the not too distant future. Right? So thank you all very much for watching. And I am going to say goodbye, and I will see you soon. All the best. Bye-bye.